Okay, welcome back. We're on page 264 talking about how to find all files that don't have a current user. So here's how it will be done. So I'm going to use the find command. And find command basically says, where do you want to start with? I'm going to start with /. That kind of makes sense. And then I'm going to give it two options. One of them says xdev. And what this basically means is stay on the same device. In other words, don't follow any links to go to. If I have a mounted folder over here, don't go into the mounted folder. Just stay on this one device. Okay. Okay. And then the other one basically says no name, which means I don't have a name. It's out there, but I'm sorry, it's no user. Excuse me. No user. And this is going to find every single file in the entire system that is orphaned, where they used to have an account, but they don't anymore. And so these things, I'm not going to hit return because, first of all, I'd have to use SU to be able to get anywhere meaningful. And I just want to show off the command. So that's the thing you would do. All right. So I want to get files that don't belong to users and hopefully look at them and decide whether or not I want to A, delete them, or B, adopt them. Okay. If I wanted to find a file belonging to a particular user, you could do this thing called UID. So I could say UID 1000. Okay. And that's probably not a very smart thing for me to do because I didn't run, yeah. Okay, I got a lot of error messages. But anyway, so here are all the things that belong to me. Yay! Cool. So with no user, it gives you nothing. Or I could say user ID, and it'll tell me exactly whatever user ID. You can do it by user name with the user option, or UID by number like I did. Okay, so on page 265, they talk about locking an account. So the whole point of an account is just to temporarily disable something. I don't want to delete them. I just want to temporarily disable them. And the scenario I just gave you was you got somebody that's going to be going on vacation for 2 weeks. And or let's say, I don't know, they're going for a long time. They're going for 6 months. And you don't allow any remote access. So you just disable their account. Poof. And then when they come back, you just re-enable it. And so there's a user mod -L, L meaning lock. And what this does, if you were to ever go look inside the etc. password and etc. shadow, it's going to put an exclamation point at the beginning of the hashed password field. Now, there is a problem with this, is that whenever this occurs, there is no indication whatsoever to the user that why the password failed. Okay? I mean, what happens is, let's say they came home early. From other than 6 months and didn't tell you. They showed up at the building and said, well, let me log in. It's just going to come back and say permission denied. It's not going to tell them why, which is a little spooky. Because then they get excited and, well, I say, hang on, let me just unlock your dang account. Okay. Anyway, just saying. There's an alternate technique, which is a little bit more mobetta, and that is you create a new shell. Okay, a brand new shell that basically says your account has been locked for the following reason. Now that, when you go in and you would have to, now this one you have to run the change shell command on them. So run the change shell command on that user and point it to this bogus shell. All it has is a warning message and an exit. That's it, that's all it's got. But at least they'll be able to look at it and go, oh, well, okay. Yeah, I need to call the administrator to get my account unlocked. Oh, okay. Rather than just saying, I have no idea why it didn't work. Okay. On page 266, they talk about the other technique, because up to now, everything we've been talking about is just file-based, which of course is not great. This pluggable architecture, pluggable authentication module. So anyway, the idea is that, the login and the sudo and the password and all these other things can be used on any system anywhere. It's all centralized, okay, using this PAM system. There are some choices. LDAP and Active Directory is an excellent choice, particularly if the Linux boxes in your organization are a minority. In other words, like 80% of the machines are Windows and 20% are Linux. You might want to consider getting the Active Directory plug-in for Linux. Okay, so this is mo better for a lot of reasons. First of all, I don't have to go around to everyone's files, everyone's machine and tweak things. There's another one called application level single sign-on. You probably heard those kind of single sign-on thing. And the idea is that there would be some sort of a mapping between your Linux authorization and like your name and password for your, I don't know, email system. Okay, just as an example. And so you could tell the machine this account is the same as this account. And so whenever you ask for a resource, it says, hang on a second, let me go look at your aliases, so to speak. And it'll use that instead, a single sign-on kind of thing. Microsoft has done an excellent job of creating an environment where single sign-on works fairly well. For example, when I connect to my cloud services, which we're going to do here in just a few minutes, I don't have to have another account. I just use my Microsoft account. When you log into Canvas, the very first time you log into Canvas, it's going to ask you for a Microsoft authentication, so single sign-on. If you're at the university and you sign on to your machine using a Microsoft account, you click on Canvas, it doesn't ask you anything at all. When you're at home, when you're not signed into that, it's going to ask you, is this the account you use, right? So it's a really cool system, and I kind of sort of like it. Okay, so single sign-on is good. First of all, if I have 5 systems that I have to deal with, I do not want to have to remember 5 usernames and 5 passwords. That just sucks. Wouldn't it be so much better that just pick one and have it all work? That's the beauty of single sign-on. And then, of course, there's an entire identity management system. Typically, these things are web-based, but we're not going to go into that much detail. Okay, so that's the end of Chapter 8. So now, let's talk about Chapter 9. Okay, so Chapter 9 is on page 270. Is about cloud computing. And quite frankly, we're not going to use our Linux machine for that, so just bear with me. So the idea is that cloud computing has been around for quite some time. It is not incredibly new. Quite frankly, what happened is when the internet became a little bit more mature, cloud computing just popped out of the shadows where it's been for quite some time and said, hey, I'm ready. So now cloud-based services are fantastic because the internet has finally gotten enough speed to make those things a viable thing. So on page 271, they talk about the things that you can do, the context of all of this. So first one is you can move your whatever you're doing. Let's say you have a web server. So I'm going to move my web server to a more technically advanced infrastructure, one where somebody else is taking care of it. Maybe it's being duplicated in a different location, that kind of stuff. I mean, it always has the latest and greatest hardware, all that stuff. And there's some economies of scale. If I'm running 2 web services, I'm probably 2 web servers. Then, if one machine needed a little bit more memory than the other one, well, just tough. I mean, I would have to shut the machine down and pull chips out of one and stick it in the other, but that's kind of dumb, right? Well, cloud computing makes that all that trivial. So you have an economies of scale. I could have 100 machines on a cloud for about the price of 2 or 3 physical machines. Remote management, well, duh. I mean, when I have cloud services with Microsoft, and I don't even know where it is. So, of course, it's going to be remote management. Okay. And then this last one, which is really, really, really the most important one. Hint, 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 hint. Like, maybe that's going to be a test question. Okay. It's called elastic scalability. Let me just explain what that means. Okay. Let's just say you have a seasonal business. Like, I don't know, a tax prep service. Where during the month of June and July, you hardly need any compute power whatsoever. You need a couple of machines with maybe a little bit of RAM and maybe like 2 cores. But come, March and April, well then I need like 8 cores and 16 gig of RAM. Now how would you do that in a traditional environment? Would you? Would you really, at the end of tax service, shut your service down and pull stuff out of your server and sit it on a shelf? No. which means you're paying for that extra memory and that extra CPU year round, whether you need it or not. But in the cloud, I could be paying for 2 cores and 2 gig of RAM, and then April comes around and I just turn it up. I go to my cloud-based system and I just grab this little configuration knob and ratchet up. I want more CPU. I want more RAM. I want more network. I want more disk. Just turn the knobs up for a month. And then after the peak has occurred, you turn it down. And they only charge you for how much you've used. So for that 1 month, my bill is going to be high. But for the rest of the time, the bill's going to be low. Got it? Okay, good. All right. So, by the way, it's not cloud computing does not guarantee you're going to always get the lowest price and the highest performance. You know, I'm sorry. Moving things across the web is not always right, not always perfect. Okay, so there's some choices on page 273. They show some of the choices. Now, I use one called from Microsoft. It's called Azure. So this is my Azure account on Microsoft. So there are several different types of cloud services, not necessarily the one I just showed you here, but there's a public one, which is kind of what we're talking about, a private one, which means only a couple companies are allowed, and then a kind of a hybrid. So having said all that, let's say I'm a big enough company that I can do a private cloud. Okay, I'm IBM or something, and I've got people scattered all over the world. Instead of paying Microsoft to host my cloud services, I'm going to do it myself. I'm going to create cloud services just for my company. No one else can get to it, so it's a private cloud. The problem here is now I don't have those economies of scale. In the Microsoft scenario, this server that I'm using is probably being also used by, I don't know, 60, 70, 100 other people, so it's driving the cost down. If I'm using 100% of the server, well, I have no way of spreading the cost around, do I? So private clouds are kind of intriguing, but they're not cost effective. You use them for all sorts of other reasons, but not because it's going to drive your costs down. No way. Okay. So service fundamentals on page 276. There's an awful lot of definitions here, and unfortunately, we're going to have to go through them. And I know I hate things that you kind of have to memorize, and this might be one of them. Okay, here we go. The first one is called infrastructure as a service. And infrastructure as a service basically is sort of like how we did VirtualBox. VirtualBox said, okay, how many CPUs do you want? How much memory do you want? How much disk do you want? And that's it. All they basically did was give you hardware, and you had to install, right? You had to install the software. You had to maintain the patches. You had to install apps, right? So that's infrastructure as a service. Okay, now that is available in an awful lot of things. Now let's talk about what that means. What that means is, if I want to reboot my virtual machine, I just say, well, I would like to reboot it. Well, in the cloud, I have a virtual machine right here, a virtual machine, a Windows 2012 R2 setup. And if I want to reboot this guy, I just log into him and reboot him because I'm the only one using this guy and I don't have to ask permission, right? Okay, that's what infrastructure means. Infrastructure is bare metal. I have to do everything. I am the administrator on the machine. I'm the one who goes and gets patches. I'm the one who decides to reboot. Nobody else is involved. It's just me. Okay. The next one is called platform as a service. And, doggone it, we're coming up on the 15 mark. Hang on to that thought, and we'll get back to it in just a second.